Hello and welcome to Essential Math Skills for Science video. In this one we're looking at drawing line graphs. Now you may have seen a previous video in which I talked about different sorts of graphs, and I said you can have bar charts or line graphs or scatter graphs or pie charts. Now we're going to focus here on line graphs. So what did we say about line graphs before? We said that, imagine you are taking height of every child in your school, of all your friends. You're going to find that when you put it into a table, you've got some very short, not very short, but short people here, and some quite tall people here. And you've got everything in between. Now this is said to be what we call continuous data, because you've got measurements all the way across the range, from shortish people to tallish people. And we said for continuous data we use what's called a line graph, and the line graph is shown here. Let's look at how we can construct a line graph. First of all, here's our data table. Now for the first 10 days in July, what I did is to go outside at midday and I recorded the temperature. So on the 1st of July it was 20 degrees Celsius, on the 2nd, 22nd and so on, and 27 on the 10th. So we've got a whole range here of data showing the temperature in degrees Celsius at midday. Now what we've got here are two things. The day is what we call the independent variable. It's what's changing, isn't it? It's first, second, third and so on. Now that's the independent variable, and the independent variable always goes along what we call the x-axis. And beneath that we've got what we're measuring. Now what we're measuring is called the dependent variable. What we measure in this case is temperature at midday, and that goes along the y-axis. Now can you remember which axis is which is x, which is y? Well, the x-axis, this is for what we call the independent variable. So in our instance the day will go on the bottom here. X, don't forget, goes across. Easy way to remember it. X across, get it? Easy way. On the y-axis we're going to put the dependent variable going up the side. Let's start first of all by setting the graph, and here we're putting in the day in July. Well, we should always start with 0 really. No, there's no date on 0, but we start at 1. I don't know why my computer's putting these dots here. Unnecessary, ignore them. 1 up to 10, these are days in July. And on the y-axis we're going to put the temperature in degrees Celsius at midday. Now we know the highest temperature was 27, so we want to spread our data out. We can go up in 5s, I think. 5, 10, 15, 20, 25, 30 fits perfectly. So all the results here are accommodated here. Notice we're starting at 0 again. Now some points. First of all, try to use as much of the graph space as possible. So you should be at least half the available graph area, if not more. Label the axis clearly to show what your numbers are. So down here we've got day in July. Up here temperature. It says there degrees Celsius midday. So don't forget to include units if they're needed. Here they are needed, so degrees Celsius goes there. Now axis numbers need to be equally spaced. Each here going 5, 10, 15, 20. We're not going up 4, 7, 9, 16. Keep them regular, equally spaced as we show there. And most importantly, use a sharp pencil and a ruler. Very important. Now we can start plotting the data. So on 1st of July, day 1, we know it was 20 degrees Celsius. If it helps you, you can draw very faint lines, okay, going up and going across, and that's where your cross goes. The second, it was 22, third it was 25, and so on. Okay, so keep going along and just complete your graph. You'll end up with a graph looks like this. Okay, all these crosses here are the points from our table of data. Then all you need to do is to actually join the points together. Notice we don't go down to 0. Okay, the data starts at 1, which is when you start plotting it, and the data ends at 10. We don't go any further, so we only plot the points where we have data. So pretty straightforward. You reckon you could do it? Well, here's a couple of examples. The following table shows a range of shoe sizes for students in the school. Plot a line graph to display this data. So shoe size, small feet 2, big feet 11, and here we've got number of students who have got shoe sizes fitting those categories. So plot that graph. The second one a bit more involved. Here we've got the number of daisies and dandelions recorded moving away from the base of a large oak tree. Imagine a big tree, and we are counting how many daisies and dandelions there are every metre away from the tree. Data is given below. You need to draw a line graph to display this data. Number of daisies and dandelions will share the y-axis. Remember your y-axis? Okay, so you're going to up there for both daisies and dandelions. What have we got? So daisies goes up to 30, dandelions 24. So if you went up in 5s, 5, 10, 15, yep, you got it. You get 30 there. Now, they will share the y-axis, one colour for daisies and the other colour for dandelions. You end up with two sets of points and two lines. Okay, pretty straightforward. Have a go at it. So that's how we draw line graphs. Hope it makes sense. Have a go at the examples, and I hope to see you again in the video. So bye bye for now.